right. So today we have Tom Smoker, technical founder of WhyHow.ai. So Tom, welcome to the podcast.
Thank you very much for having me.
So I guess let's open with one of the hot topics of the year, which is GraphRAG, which I will loosely describe. I don't know how you feel about this. I'm kind of loosey goosey about this, but basically, it's it's RAG with a graph or knowledge graph component. So, however you want to add the knowledge graph as part of the retrieval process, um, at least in my definition, you're allowed to add it in however way you want, right? Because there's different design patterns. In fact, I wrote a post with a friend where we tried to read and watch videos, and we came up with a few of these design patterns, but there's no consensus. So, with that said, do you have a much more strict definition of what GraphRAG is?
Maybe less so. I think my definition changes based on context. I think you may be referring to the work you've done with Prashant,
Yeah.
but who I know and I very much like what they produce in any semis writing. I'll read. When it comes to GraphRAG, you're right. The RAG and a lot of what I spend my time doing is the R in RAG, right? How do you retrieve? And I think that in theory and sometimes in practice, the retrieval can be better if it comes from some sort of structured data, right? If you have a structured query language and you have structured data, you can retrieve more consistently, often more compressed, you know. Yes, for a definition, there is no definition of knowledge graph. During my PhD, it wasn't very easy to cite. Um, but I think OntoText does describe knowledge graphs quite well. I think if you have to lean on a definition, I'm a little bit partial to theirs. When it comes to GraphRAG, I'm yet to find a definition. I just know you want to bring in structured data, you want to use something, and however you want to refer to it, just kind of meeting people where they are.
Yeah, in fact, I gave a talk recently where, I talked a little bit about GraphRag, but I said, at the end of the day, as you point out, Tom, the lesson for me is structure.
Mm-hmm.
So if you have structure, so sometimes the structure is a SQL database, right? So
Yeah.
yeah, and so sometimes you can infuse the RAG query with a query from a SQL database. That's fine, right? So sometimes maybe you have structure, but it's short of an actual graph, right? So
Yeah. Yeah.
maybe just some metadata or whatever, right? But
Um,
but if
yeah.
you have a knowledge graph, obviously great. But don't lose hope if you're struggling to do what you believe is GraphRag because you can't get to a knowledge graph, right?
Not at all. A definition I do like of a knowledge graph, which isn't necessarily published, but it was one of my PhD supervisors, Tim French, talks about a knowledge graph is a knowledge base and then a list of axioms, right? And that's a very philosophical definition. List of axioms like rules and reasoning are obviously relevant, but when it comes to the knowledge base, a fundamental knowledge base for knowledge graphs is just a set of triples. It's just a word connected to another word through a third word. And again, these could be series of words or strings. So if you have that knowledge base, you have compressed structured data, right? Now, if you want to visualize that as a network and run graph algorithms on it, you can. But fundamentally, the benefit is even just a .txt file with a list of triples, right? But the value is in that you've extracted and consistently defined those triples. So not necessarily having that is okay, but any attempt to get yourself from I have a lot of unstructured data to I have a list of slightly more structured data is valuable when it comes to retrieval, both from how specifically you can refer to it and then also how compressed it is. So yeah, fear not if you don't have a fully structured graph like the Pinterest or the LinkedIn team do. The value is in structuring the data how it matters to your use case.
By the way, yeah, so you've been working on knowledge graphs before knowledge graphs became cool again, right? So obviously now knowledge graphs are cool again because of AI and more recently because of GraphRag, right? So before we dive a little bit deeper into GraphRag, so what are you what are your two favorite examples of actual GraphRag in production being used? Can you
So,
name two?
yeah, of course. GraphRag in production.
It doesn't have to be
Um,
yours, by the way. It doesn't have to
no.
be.
It won't be when I look to because if I want to really look at and yeah, so just to give context, I did my master's in expert systems and ontology in 2016, and then went on to do a PhD in knowledge graphs and knowledge graph embeddings. So I have been working on it since before they were cool. They definitely weren't cool at the time. when computer vision was really taking off. But natural language, definitely. But no, the examples are people who've spent a lot of time describing what I just said, which is structuring their data so it's consistent. And then now, as you can do RAG, right, you can bring in structured information to a context window and an LLM can summarize it or do something with it. I think the decade that people take in structuring that data is important. So again, I'll mention teams like LinkedIn. LinkedIn and BlackRock has a paper. I'm a really big fan of Ure and his work as an academic and at Pinterest. So I think Pinterest Knowledge Graph is fantastic. But those are the best examples to me of existing graph structures that are fantastic when they work. And then for a case that I like that's new and maybe a different application, it was a veterinary radiology example, which I think is bizarre, but it was very niche, very specific data that needed to be retrieved. And it just controlled the edges of the hallucination for a radiologist. And I liked how specific that was. They kept asking questions to an LLM that will remain nameless, but is otherwise very well performant. And it kept, even though the radiologist specified it like they wanted to, it kept recommending conditions applicable to Labradors, not Bulldogs. And they could not convince it that the Bulldog was what they were working with. So GraphRAG in this instance was a very useful way to say, look, all I care about is Bulldogs right now. I can't prompt myself out of this, so I'm just going to make sure that you know that I'm in the context of Bulldogs. And I did like working on that because I thought that was quite a bit of a bizarre use case, but it was interesting.
And in that case, Tom, the underlying data, was it primarily text?
Yeah, primarily text. In fact, it was processed academic journals and then textbooks. So yeah, almost exclusively text. Mostly because the radiologist's job is to analyze the image and then describe, what that image is. And fascinating in veterinary radiology, animals don't sit still, so it's difficult to build up a consistent data set that you can train on. So the radiologist still needs to apply their existing knowledge, and they'll be like, oh, I know that there's this condition, but I can't quite remember. I would like an assistant that immediately retrieves for this case, and so they can set context as they work and then speed up their workflows.
So let me throw in a couple of my favorite examples. The
Please.
first one is from Google, which I'm not actually sure if it's in production, but at least it's a blog post. It basically uses their Google Data Commons, which has billions and billions of points, and it's part of, I suppose, what would be a Q&A application of some sort,
Yep.
right? So, and then the second example is from Metaphor Data. And Metaphor is a startup that builds tools for knowledge management. So basically, they have, they go through all of your data sets, and the end result would be something like, I guess, figuring out what, it will help you do data discovery and data governance. But basically, what I find interesting about it is the starting point might be structured data information, and then they use that to extract a knowledge graph using metadata and those sorts of things, right? The schema. So nothing special there. And then then they take that graph and they create a second graph which maps basically those technical terms to business terms, right? So because basically, as you know, the technical people may name columns in completely incomprehensible ways, right? So that business people cannot comprehend. And then finally, then they take that, they then construct a social graph based on who's using this data, what's their role, and when they create a table, who else is using that table, right? So in other words, not just mine information from human resources, which is what is Tom Smoker's title and who does he report to, but basically when Tom actually does data work, who actually works with Tom, who uses Tom's data sets. And so basically they create out of basically seemingly structured information, they create 3 different graphs, and then they use that to power their application, right? So again, what I find interesting about it is they don't stop at one graph. They use the same information, create even different views. And then secondly, actually, they're not actually even necessarily using unstructured data as their starting point, which is, again, something, I guess, Tom, I don't know how you feel about it. I think sometimes people miss the fact that their structured data can be the basis of a nice graph.
Absolutely. Yeah. I mean, if you to get I don't want to get too technical, there's a bunch of great writing about it, but if you look at how vector databases vectorize and analyze, I mean, a lot of the you know navigable small worlds, hierarchical navigable small worlds processes are using kind of some sort of like index to figure out exactly where you should be. So yes, to that point, unstructured data is really valuable. You don't need exclusively structured data, but you do need a way to navigate and categorize unstructured data, right? And so if you are using a graph or tiers of graphs, I think that's it. And we've set systems up like that before, in that like what the graph can be is a very useful and in context discretization of a search space. And so if that search space is then triples, that's great. You've again further controlled the navigation in the way that you want it. If that search space is unstructured and embedded text, that's still fine if you've navigated yourself to that point. And once you have, again, discretized a search space, pre-processed a query and mapped it to where you need to, then you can get all of the benefits of, semantic search on text embeddings, which I still think is any sort of hybrid process. It doesn't need to be in parallel, but a semantic search on text embeddings is still a fantastic way to work. It just depends on where you put it in your workflow.
So, Tom, I think at this point, it's fair to say that RAG is kind of the hello world example for generative AI for most teams. So, where are we on GraphRAG? Because you're out there in the field. Do you still feel like you have to explain what GraphRAG is and explain what its value? Or are we at the point where people know what it is and you're just helping them implement?
I would say more so I have to explain it than I did previously. I mean, before Microsoft came out with GraphRAG as a description, because there isn't necessarily like vector RAG, there's just RAG, right? And it's assumed to be vectorization. But there is also, there's relational data, there's no SQL, there isn't necessarily names. So when we say GraphRAG, is it Microsoft's GraphRAG package? Is it like who exactly are we referring to and what? And for most people, in my experience, they want accuracy in the beginning, or at least the hook is more accurate. The value often is more explainable once they get to that point. And so also educating people on, yes, I know you saw a great example of a Pinterest or a LinkedIn, like I'm referring to, or a Klarna, someone's fantastic graph, and you're like, I would like that, please. What you don't necessarily see is the iterative process in schema design and what was left out and how that graph was connected. So I think I spend a lot of time explaining to people that the upfront cost of these systems is non-trivial, and while AI has reduced it a lot, it's still an effort to get going. It is worth it in a lot of use cases. In some, it's absolutely not. So no, I find myself having to, more people know about it for sure. It's been great for us as a business, but the variety of use cases that come to us is more than it was before. And so and also as a final point, there are many different ways it can be used. There's not one consistent solution for GraphRAG, right? So no, I find myself explaining it more.
So, what are some of the key bottlenecks? I guess one thing that jumps out right away is how do I get a knowledge graph?
Yeah, I mean the biggest bottleneck is well, the biggest question is, do you need a graph in the first place, right?
Right.
Like, it's not like you go from unstructured data to graph. There's a full spectrum of how you can structure, how much structure you need. Are
Right.
you
Right.
ontologically aligned? How hierarchically consistent are you? There's a lot of questions. And to be honest, most people, it's in their best interest to stop before they reach that end goal because they have, managed to get the majority of the value out of that before there's diminishing return.
But
So
is it fair to say, Tom, that you talk to a lot of people who've already tried rank, and
yes,
then they're trying to take it to the next level, so to speak.
absolutely. In fact, I would say for some people who come to us brand new and are like, we've heard of AI, we would like to do GraphRAG. Often it's encouraged to be like, look, you have a data science team, you have existing ML systems. You should try VectorRAG first. If it works for your use case, then that's a great solution for you, right? It's so accessible, and trivially in terms of cost to just embed and retrieve with the systems that we have. So if that doesn't work for you, then there's a lot of value that structuring your data can provide, all the way up to a large scale, graph for analytics, right? Like that's really that when you get to that point. But yeah, if someone comes to us brand new, it's like, look, you should try VectorRAG and see which of your use cases this works with and why.
So when does VectorRAG work for someone?
It's a good
No,
point.
so you have to have some tolerance for inaccuracy somehow, right?
Yeah, but so it would be if the chunks are really well structured,
Yeah,
like
yeah,
if a
yeah.
lot of
That's
the
true.
work is done up front, right? So if you can,
It's
if you have,
expensive. It's expensive, but that does work. Yeah.
yeah, we put out an example of recursive retrieval on legal contracts, right? Where we were able to find, and this example is public, but you can, specifically mentioned in the footer of a page. Sorry for my accent, but in the footer of the page, there will be, by the way, if you read clause 6.2, make sure to also reference clause 7.5. So how do you navigate through that in the way that a human would? A lot of that work was upfront in terms of how do we extract and then label and then navigate through that structured information. We used a service called Reducto for that, which is a great startup, but at that point, you get a lot of value out of VectorRAG because you've structured your information well. Legal contracts, academic papers especially, often have to follow a certain structure. So there's value in the extraction. If you're just naively splitting on chunks, then yes, like that's a difficult thing to get value out of. If you spent time making sure you know what the chunks are, where they're split and why, and they're well labeled, you use good metadata filtering, I think you can get a lot of value out of VectorRAG.
So for people who have already kind of squeezed as much as they can out of RAG. So in other words, by that I mean they've run experiments, they've turned a bunch of knobs, and they've heard about this GraphRAG concept. They don't have a knowledge graph. So what are some of your pointers for how to get started? What are some of the initial steps they can take?
Yeah, and I might link this to motivation as well, because like again, there's a non-trivial input amount of like to get to this point. A cell that I think people underestimate, but it is more and more relevant in an agentic world, is that the knowledge base I described before is often a compressed representation, right? And that compressed representation is less tokens, right? And less tokens means better rate limits and less cost when it comes to large scale applications. So for some people, they can be like, look, our solution already works, but doesn't scale. It's like, well, something like a graph can be useful for you, or at the very least structuring your data in such a way. So that would be a start. The second is like, I'm a non-technical person, but I'm a domain expert and I don't know why these things are happening. This system is a black box and I would like it to be explainable. And so to that point, it is okay. For it to be explainable, you need to understand what was used and why. And so then getting that information into a structured representation and then being able to trace back that structured representation, especially visually in a graph, can be very useful for people who aren't necessarily technical. So this comes down to structuring information. Now, as a first pass, when you say, how to do this, it is extracting in a consistent way. For a lot of people, using something like a Pydantic or a JSON is actually a really good first step in terms of being like, this will be nested, hierarchical, structured natural language. Now, there's a variety of ways to do this. The simplest way is prompt an LLM and ask it to extract for you, right? You can do NER if you want to. You can have systems, but it's like start getting your data in more of a structured way. Yeah, and then
So now we're getting into a topic roughly called, I don't know if this is a fair description, Tom, but some sort of automatic knowledge graph construction, baby steps.
yeah, we put out a post the other day that says automated knowledge graph construction creates bad graphs, and I very much stand by that. It does, and it's
It does. It actually does. Yeah, yeah.
now what I will say is I've built a lot of graphs in the past, and I've been involved in large scale, 3-year $1 million projects of building large scale graphs in systems.
By the way,
Yeah.
before you continue, so automatic knowledge graph construction builds bad knowledge graphs.
Mm.
Generally, I think that statement is true, but Tom, in the context of GraphRAG, can automatic knowledge graph construction build a good enough graph or GraphRAG. By good enough, I mean I I build this automatically, this knowledge graph, and it gives me some sort of lift from plain rag.
Uh, all of that is context dependent. There is not one answer that answers that. I would say in few cases, yes. But look, if you're going to go through that, what I think a lot of the point of that post was, look, if you just say, make me a graph and press play, you didn't really do it with any level of intention. And so the value of it is lost. And why did you not just add metadata filters to there's so many
Right.
other
Right.
ways you can lift it. I mean, you look at, if you follow Jason Liu's work around like what does it make to make a good, RAG system, look at your data, pre-process, like all of that is so much more valuable than just pressing play on an automated graph. But what I will say is that it is an iterative process and spending time with it is there. The value is starting that process. If you want a more accurate, more explainable system from a graph you press play on, I would doubt it would have much lift over vector RAG, and that's a lot of what we've learned.
Yeah, I mean, I think one of the almost immediate lessons from RAG when it first started was metadata filtering. Right?
Yeah,
Yeah, I mean,
and I still think that's really useful. I mean, it was early when, and different, it can be a way to differentiate between different vector providers in terms of what metadata filters do they offer. But we absolutely use metadata filters all the time, and I think it's really well controlled. I think understanding exactly how to filter and categorize is really useful. So to that point, yeah, what does it take to? I think any time spent structuring your data better requires you to probably have to understand your data better. So if you make a bad graph automatically and then you know why it's bad, there's business value there, there's intellectual value there. But the likelihood of it improving your system with a level of accuracy or explainability is, I would say, at best, slight. And there's also downside risk that you thought it worked and it didn't. And you got tricked into explainability and all you really did was extract the wrong thing. So there's the chance that making a graph makes it worse. And I feel like that's not talked about much.
so as we mentioned, you've been in knowledge graphs for a long time, right?
Hmm.
And uh, to our listeners, there are actually some companies and industries where they actually have knowledge graphs.
Yeah,
You can imagine someone maintaining logistics somewhere or for fraud detection, right? So these kinds of things, right? So there are industries where they actually actively maintain a knowledge graph for a variety of reasons preceding the rise of AI, right? So in those domains and sectors, Tom, are you starting to see them do GraphRank?
absolutely. Yeah. And so I will say, like, there is the, Python package rapidly growing LLM part of our world, which is, should I use a graph now? Can I add structure to my RAG system? There's another world which I'm still very much a part of. The mutual friend of ours, Paco, is him and I have talked about it a lot. But I was recently at ISWC speaking around the semantic web, and it definitely, and I think the industries, to be explicit, healthcare, finance, those with large scale ontological consistency. And to speak to my background, I helped develop some large-scale formal ontologies for maintenance and mining in a past career. Yes, there's two main reasons that those groups are starting to use RAG. One is, again, we've spent a lot of time building this system. It would be nice to increase the ROI of this consistent database,
And
right?
they're actually also these people actively maintain these graphs.
Yeah, and to the point that they've been maintaining them for a long time. So these are actually maintained, consistent, live graphs that are not just a proof of concept, are often active in production, working in systems, well before we had large language models accessible through APIs, right? So yeah, absolutely, those industries, and so they are looking to get more value out of it. They are also looking to the benefit of RAG, and something we can speak to if you want, is now more people can access this data, right? If we have a natural language interface, which is a difficult problem to solve, but if we have a natural language interface and we have this consistent data, then all of a sudden many more people, either internal or external, can access this data that we've curated over, for some people, decades of expert value and expert knowledge. So absolutely, those two reasons: one, getting more ROI; second, bringing more people to it.
So For people who are not in the space, right? So, and I don't consider myself in the space. I'm in the fringes of the space, right? So, there seems to be two communities, right? So, there's the semantic web,
Yeah.
RDF people, and then there's the property graph people. Can you give people kind of like a very high level uh, uh, definition of these two worlds, and are these two worlds merging? Give us give us a status update in
Yeah,
light of
yeah.
GraphRAG. In light of GraphRAG, what's the status of this graph communities?
Certainly, and I think you sell yourself short. I think you've been around. I think you've seen it come and go. I like to think about it again. I was in my degree. I think there was a Bayesian versus frequentist in statistics. There's that argument, right, of these very like dogmatic groups of people against each other, and I've often seen them similar in that property graphs are the easier, maybe the more accessible, and then the RDF world is the more consistent, the more specified. Um, in those worlds, I haven't seen many people change their minds, but what I will say is that when property graphs came out, there was a level of controversy around, isn't this weakening the value? Because a lot of the value in these RDF systems is not just the data representation, it's the reasoning, and that reasoning is deterministic and symbolic and consistent, right? And so any weakening of that is a weakening of how consistent that reasoning is. I would say that in the age of LLMs, most people are just trying to get started. And I would also say that it is difficult in the age of LLMs to create a monolithic, well-described, upper or top level ontologically aligned structure such that it represents everything you need and can adapt to the future. So what I do see is there are some use cases where RDF is useful. It was already useful there. I don't really see many new use cases coming to RDF. I see a lot of people, the benefit of property graphs, LPGs, is that it's much easier to get started. It's already hard enough to get started with a graph system, right? So making it any harder, RDF you require, or OWL or any of those, you require a lot of specification. You often require a specific query language, such as Sparkle. You require constraints such as Shackle, a framework like RDF, and then often systems that require you to put it in there. Now, for some people, that's absolutely worth it. For most people in the RAG world, no. Because of this, all the cool new things are happening in property graphs, and I definitely feel like people in the RDF world are looking on forlornly. And to be frank, I'm probably one of them. Who my main supervisor was a logician, and I spent a lot of time in representation and description logics, and that's a real passion of mine. So there's definitely part of me that will always love the semantic web and representation. But if I'm being realistic, I think that most people are spending time in property graphs, and I don't see many people progress from property graphs into a more structured, more deterministic system. One caveat I'll say is that I've seen some interesting work around JSON LD lately. JSON LD being an extension of JSON that allows ontological consistency. And because that is in a lot of the web training data, it's actually in a lot of LLM training data. So LLMs are actually quite good at understanding JSON LD as a structure. And so I think that can be really useful. But yeah, generally it's I'm not seeing many people progress through to RDF. People who already liked RDF still like it. Most new people are going to property graphs.
Yeah, it seems like, as you point out, it seems like GraphRAG is really property graphs.
Yeah. Well, I mean, you could actually even say that, like, is GraphRAG even I think there's the bigger question is not, is it property graphs versus RDF? It's like, is it graph structures at all? Or is it just structured data, I think? Because, like, that's a spectrum of
Right.
how hard is it to get started versus how much value does it give versus what is the diminishing return. And for a lot of people with RAG and natural language, it's like, how much more effort do I want to put in for this diminishing return? So do I need properties at all, or is it enough to just structure it? Do I need structure at all, or is it enough to do short text instead of long text? Those are more of the conversations I see. But yes, it's hard enough convincing people to use a property graph, to be honest.
So let's close with something that tech people don't like to do, which is to
Mm-hmm.
make predictions.
Okay.
So 2025, GraphRAG. At the end of 2025, where will we be in terms of GraphRAG? Will it be as common as basic? It becomes so easy to do that most companies will now have some sort of GraphRAG system in place. By GraphRAG, loosely defined as we agreed on at the beginning.
Yeah, well, if I'm able to take my tech hat off and put my academic hat on and postulate a little more,
Yeah.
um, I think that the RAG world defines that much more than the graph part does, because I think it's very much defined by what are the useful RAG use cases. And you can say that progress in RAG has been slower than people expected, and you can say that it is starting to verticalize and there is starting to be value. But overall, if I take a broad temperature of the community, RAG is not quite as valuable as we thought. So I believe structured data, I'm going to say structured data will definitely be important. Is it graphs? That is difficult to know, because then it comes down to, like, will it be in graph databases, which is, I think, a big question. There will be some specific use cases, like we mentioned, Prashant, before, and the analytical use cases and the embedded process of that. I do see that growing. I see structured data growing, but I see people storing that structured data uh, in different circumstances that aren't necessarily graphs. There will need to be more structure and more explainability. And when it comes to the agentic future that we're all promised, there will need to be a reduction in tokens for people to be able to justify the cost. So, yeah, so I would say we will still be talking about GraphRAG similarly at this time next year, but there will be a much easier understanding and many more people will have structured their data.
Yeah, and this makes me happy because I wrote a newsletter article. I think I called it "Structure is All You Need."
I
So
saw. I very much appreciated that. In fact, was
yeah,
I doing a talk? I was also a little bit like, I wish I'd coined that term. Um,
and actually, Tom, you bring up a good point about RAG, which is basically, I think for people who haven't tried doing RAG, very rigorously, they have this mistaken impression that, oh, I have RAG, so no more hallucination. But the reality is, reality is the LLMs have priors, right? So
yeah,
the LLMs have opinions. So you can prompt the hell out of the LLM and tell it, hey, only use what I'm putting in this context window to formulate your answer, but it still will try to opine outside of that, right?
oh, absolutely. I mean, I speak Australian English, right, which LLMs have a hard enough time understanding. I have a great friend of mine who's Polish. Similarly, our English just does not, like, we have a harder time prompting, let alone, I think a less spoken about part is that if you try and prompt, you're very much in the OpenAI prompt world, right? Whereas if you try and use any sort of like local LLMs or any other provider, those prompts aren't optimized. Most of the world has been, hyper optimized for better or for worse in the way that OpenAI prompts. I'm going to give two quotes from Andre Karpathy, who's one of the best, as we know. The first is that we don't have a hallucination. Well, LLMs don't have a hallucination problem. LLM assistants and AI assistants have a hallucination problem, and I think that's the best way to think about it. And that LLMs hallucinate by design. They are generative models. They are supposed to make things up. The LLM assistants, how they handle that hallucination, presents itself as edge cases to us, and that's the frustrating part. So it's a matter of software design as opposed to models. I think that's where to focus. Second, Karpathy said just the other day that when you're speaking to an LLM, you are not speaking to an expert. You are speaking to the average of the data labelers that contributed to this model. So when it comes to things like RAG, it is not magic or an expert. It's really just a consistent. So how you use it is, think about it. You're speaking to the average of the labelers, and then it's up to you to justify that label. So those points I think are very relevant when you consider RAG. A, they're meant to hallucinate, and B, they are the average of the labels. With that in mind, I think it becomes much more realistic about what we can build with RAG.
And actually, I'll close by saying that I think that next year, or I think people are beginning to realize, at least for agents, uh, the most interesting data is actually operational data in live systems, right? So think about payment systems like Stripe or PayPal, or logistics systems, FedEx, UPS, uh, and so on and so forth. Market CRM systems, right? So, but for some reason, developers are all focused on PDF files and text, right? So, but
Yeah,
I think we're gonna start seeing people come to grips with the fact that, hey, the most interesting data is in these operational systems that we have to get the right data at the right time, and that could be real time.
If you'll indulge me just for a second on a
Yeah.
soapbox, is that like when people talk about the gold mine that is unstructured data, it assumes that when you captured it really well and you just can't access it. But in my experience, there's very little effort taken to actually capture valuable data in a PDF. It's much messier than other systems, right? So when people are like, there's some great data in our unstructured information, it's like, yeah, but it's not necessarily good or valuable. And in fact, you have to sift through a lot of noise to get signal in these PDFs, right? Because they're not made for this. Whereas if you compare, and again, I have a background in mining and oil and gas, but when I look at those systems, those large scale distributed networks of supply chains, and or to maybe bring in a more digital example, networked data, right? So any sort of networks, that is where I see a lot of value. It's already structured. It lends itself naturally to hierarchy and graphs. It's a well understood problem, and it streams in consistently. You don't have to do processing. So yes, I've often thought about the holy grail of a RAG system that uses graphs, or a GraphRAG system. To me, would be where physical meets digital and it crosses legislation and process. So really, it's a large scale multinational supply chain. If you can work with that data, I feel like you've solved a massive problem. That's not coming much out of PDFs. That's
Yeah.
coming out of live stream, sensor, and logistical data.
And with that, thank you, Tom.
No problem. Thanks, Ben.